only taught when you get to do spectroscopy. But I think it is super important to figure out isomers if you can narrow down the chemical materials. For example, when we started out with ethane, right? When you start out with a molecule of ethane, and the molecule of ethane looked like this. So if your molecule of ethane looked like this, you put your carbons, and then you went ahead and you put all the hydrogens in ethane. And we're going to start naming already, right? So this one is called ethane. So I'm already naming for you. Okay, if I remove any of those 6 hydrogens, any, it doesn't matter which hydrogen I selected, if I replace any of them for a chlorine. I know I have another bond. Is everybody okay? So I know the compound has totally changed, but it doesn't matter where I put the chlorine, right? Everybody with me crazy? I'll put the chlorine here, and then these guys are all hydrogens. Or I'll come over here, I'll put the chlorine here, and these are all hydrogens. Or I'll put the chlorine here, and the rest of these are hydrogen, like that. The way that we're going to name is that you're going to number the carbons. Okay, and you will always want to number the carbon that already has someone other than hydrogen on it. So that's going to be your priority. Because I have the chlorine, I'm going to be carbon 1 and I'm going to be 2. Because I have the chlorine, then I'm going to be carbon 1 and you're going to be 2. Because I have the chlorine, I'm going to be carbon 1 and then you're going to be 2. Is everybody there? The chlorines are going to be called chloro, and you're going to have to give it a number, right? So all of these compounds, every single one of them is going to be called 1-chloroethane, yes? And this one is going to be called 1-chloroethane. And like that for the next one. This one is going to be the same, right? That one is going to be the same. So if it doesn't matter which hydrogen you're removing, and what position you're putting the chlorine in, you go back and you're going to say all of the hydrogens of ethane are equivalent. So all of these guys, all of these hydrogens are equivalent. And so we go ahead and we do several things. We either call them H1 and they all become H1, or somebody wants to call them H(a), or somebody that is like colors, paint them all the same color. So you really want to use some kind of some format that when I look at the paper, I know that you understood what equivalent means. Okay? Everybody clear with the ethane? Everybody is clear with the ethane? Okay. What happens when I go ahead and now I keep my 1-chloroethane? Right? I keep that molecule of 1-chloroethane that I just created. The chloro is here, and that's 1-chloro. I come over here, the chloro is there, and that's 1-chloro. My question to you is, are all the hydrogens of 1-chloroethane equivalent? Are all of them equivalent? I see people saying yes, I see people saying no. Okay. How many people say that they are all hydrogens are equivalent? Okay. How many people say that they are not equivalent? Okay. Remember the story is the what if. What if? If. And I know I'm going to end up with something else. Is everybody there? So I know it's a different molecule that I'm going to make. You cannot say, oh, but now it's somebody else. It's going to be something else. It's going to be another one. If I remove a hydrogen from here and put a chlorine in there, that molecule is going to look like, hold it. I need more papers. They call me the tree killer, can you tell? Okay, so if I go ahead and I remove any one of these 2 hydrogens and I put a chlorine, my molecule is going to look like that. Are you agreeing? Yes or no?
Yes.
Okay, maybe I'll do it like that. Okay, let's go like that. So I said you remove that guy, and that's the chlorine there. Yeah? Oh, what if I remove this guy? Okay, if you remove that guy, that's the chlorine there. So it doesn't matter which hydrogen you're going to remove, you will always end up with 2 chlorines in here, right? What if you leave that there and you come over here and you remove any one of these 3 hydrogens? Will you end up with that?
No.
No. You'll end up with this. I'll change that. Now you'll end up with this. Are the compounds the same or different? They're different. So then you go back and you say, are all the hydrogens in 1-chloroethane equivalent?
No.
The answer is no, they're not equivalent. If you remove any one of these 2, your compound will be different than if you remove any one of those 3. So, here's the best part of this. If I said how many dichloro compounds can you make from the 1-chloroethane, how many dichloros, you're going to say, oh, very simple. I have 2 sets of equivalent hydrogens, so I'm going to end up with a 1,1-dichloro or the 1,2-dichloro. And then that way, in a test or whatever you're working, on this side of the paper, you don't have to work too hard. Okay, so if I come back to this one again, if your compound looks like this, bless you. If your compound looks like that and all of these guys are hydrogen, I don't want to write them there because it gets very messy, very messy. If I replace them from that same carbon, you end up with this. And all of those are hydrogen. Or you end up with this. You replace it from the other carbon. These guys now, the new nomenclature, this is carbon 1 and this is 2. This is carbon 1 and this is 2. And this guy, it's going to be called your 1, 1. There are 2 chloros. The 2 chloros get the letter di, so it's 1,1-dichloroethane. And all sigma bonds can rotate, right? So you can rotate these guys any way you want to. She says, can you just rotate? You can rotate them any way you want to, but there's no way that you're going to end up here. There's no way you're going to end up here by just rotating. Everybody. So you cannot rotate to get to that. You have to pull, attach, connect. Okay, these 2, the relationship between these 2 are said to be isomers. Not only are they said to be isomers, they're called constitutional isomers. The connectivity is different. You connected the chlorines on carbons 1,1, or you connected the chlorines on carbons 1,2. Does everybody understand? All right, that's what we mean by equivalency.